Hi, and welcome to this lecture in the series of lectures on C Sharp programming. This particular lecture will cover variable assignment, including numbers and strings. And of course, it's me, Dr. Peter O'Neill of Sheffield Hallam University, presenting. Okay, without further ado, what is a variable? Conceptually, a variable is like a box with a unique name into which we can place any value we desire. Lower down in our program, we may want to refer to this box to use that value. And we will do that by using its name. Also, a variable in a program gives it memory, something we call RAM, random access memory. In a program, we can create as many variables as we need. Here we will look at the rules of introducing variables into a program. But the hardest part is deciding not if we need a variable, but what type of variable we desire or is required. The use of variables and their assignment is probably one of the most common tasks a programmer ever does. You must know about different types. For example, what is a string type? What about whole numbers? What about decimal numbers? Etc. You must know how to write a program that is easy for the next programmer to modify and understand. So when you're declaring your variables, you need to consider this too. Here is an example declaring a variable and placing a value in it. So, mark is the variable. Int is its type. Int stands for integer, which is a whole number. The two forward slashes is then followed by text, and this is a comment. You will need to use these in order to explain to the people that follow you what you're doing with this number, or what this number is significant for, or even what your code does with it. And then you've got assigning the value. So in this instance, we're assigning the value 50 to Mark. Now let's run the code. We are creating a real program or a real project and placing our code into the event of a button on our form. So we place the button on the form and then double click that button and copy the colored lines from the start of the line private void button click, open brackets, close brackets, open squiggly brackets, and we write in there int mark semicolon mark equals 50 semicolon before we get to the closing squiggly brackets. I will explain the significance of the squiggly brackets in a moment. Like here. So we've got private void button 1 underscore click button object sender event arg e. So that is the name of our event. That was created when you double clicked on the button. because the button at this point did not have a name assigned to it. Now we have our open squiggly brackets. This is where the method will start. So when you click on it, it's from this point on to the closing squiggly bracket that the code will run. So, int mark, semicolon. Notice I've changed int mark to int mark. The reason for this, as I explained in another lecture, is that I use btn underscore for buttons and int for integers and dbl for doubles and so on. I find that personally this makes it easier for me. Also, what it does mean is that lower down in my code, if I cannot see the declaration of mark, I know what type mark is actually accepting and what it isn't accepting. In this instance, it doesn't matter, because just below it, we've got int underscore mark becomes 50, semicolon. Notice there I made the equal sign becomes. Okay? And that's probably the best way to read it when you look at it as assigning a value to a variable. Notice now I've got my squiggly closing brackets. So in other words, when we click on our button, int mark gets ran and int underscore mark becomes 50 gets ran. Okay? And then it terminates. That's it. That's what it does. But what will really happen? We can see that in variables, declaring variables number 1 on the blackboard, which I've written for you to download and try. But let's take it a bit further. So what will happen? Well, the answer's nothing will happen. When you click on it, you can click on it as many times as you like, and absolutely nothing will appear to happen. And that's the point. Nothing will appear to have happened. Yeah? Because we can't see it. Any suggestions of what we can do? Yes, of course. We need to display our result. In other words, we need to display the value of int mark onto our screen. So let's give that a go. Place a label onto the form, just underneath the button. In the text property of label 1, because that's what it will be called, the label, by default, remove the word text. Then go back to your form and double click on your button and add in the following lines of code. In theory, you should already have int mark. By the way, this can also be seen in declaring variables number 2. Notice that we've added something. So what we've entered here is the following into our code window. We've got int mark and then int mark becomes 50, then label 1 dot text. Now that's important. Dot text is the actual area where the code or where the value will be held, right? Which in this case is int mark contains a value colon space, and then it's concatenated with a plus sign to int mark dot toString, open brackets, close brackets. But when you run it now, it will display the value of 50 after the word value. Int underscore mark dot toString. This basically converts an integer type, or any type, to a string. Why do we need to do that? Well, because label.text is of text type, which is actually a string type. So text is actually a string, and therefore we need to convert it so it can go into there. Notice the first half in speech marks is already text, so we're just concatenating it using the plus sign. So that's toString and explains it. So it takes mark, converts it, and then puts it on to the end of the value. Okay, what if we wish to display weight in kilos? This would require a double. For example, 65.35. Well, we can declare a double, and we can just change it round. That's not a problem. So as you can see in our code here, I've declared double dbl underscore weight. There we are. Okay. And what we've done is we've just taken we've assigned the weight underneath it with dbl underscore weight equals 65.35, and then we've replaced at the other end toString with the weight double underscore weight. And you can see that in example declaring variables number 3, which is available on Blackboard. So it will actually then change them about. Notice the structure is very much like our previous one. All we're doing is basically declaring different types and using the same structure with different text to explain what it is. What if we entered this? Int weight. Then we wrote that weight, or not weight, equals 65.35. Notice our machine has automatically put us a jagged line underneath. And if we click on the red square, it will tell us the name weight is not declared. And the reason why is we've spelt it wrong. Spelt it different. Now, it doesn't matter if your spelling's not good, mine's not particularly brilliant, as long as you are consistent. So if you always spelt it like that, it'd be happy to forget it for you. Quite happy to forgive you. Obviously, spelling's better to spell it correctly. But as I say, if you spell it wrong, as long as you're consistent, it'll be happy. But what if you do this? Int in the same area. Well, you get an underline again, and if you put your mouse over it, it would say local variable name n is already defined within this scope. In other words, you can't define it twice. You can't say it's an int. Okay? Please note also that C# is case sensitive. So n lowercase and n uppercase are different. There are two main classes of numerical variables. Integer type, doubles, also known as floats, reals, or floating points in other languages. Normally, choosing an integer is giving you an exact result, the whole number quantity. For example, it could tell me the number of students in the classroom. After all, half of you is not going to turn up and leave the other half in bed. Although you might leave your mind behind in bed. The number of locations when computer RAM. You can't have half a location. You've either got full location or you've got no location at all. The number of lines on a visual display unit. Yeah? You've got to have a whole line. You can't have half one. So this is where whole numbers are used. And they're used all over the place. The trick is to work out what type of variable you need when it comes to numbers and floats and so on. So when should you choose a double, float or decimal point or a floating point? Well, you should choose it for things like height in meters, money, yep, because you're going to have £1.99. So if you put that into an integer, right, and put £1.99 in, is you'd end up with a pound, because it would lose the 99.99, which would not make you a happy person. Averages of several integer numbers. So you can say what's number this divided by this, which might be two whole numbers. Invariably, that will come back as a floating point. So integer divided by integer often will come back as a floating point. The capacity of these types is very, very large. The capacity of these types is very large. An integer can hold up to 2000 million. That's a big number. A double can hold a value around 15 decimal places and up to 10 to the power of 308, an even bigger number. But note, double values are never exact. For example, the answer to 20 divided by 3 is 6.666666666666 recurring. Yeah. Remember, we chopped this off after the 15 digit, and therefore we automatically create an inaccuracy in that value. Integers are totally accurate though. Choose the type based on your knowledge of that problem. String variables. Briefly, a string can hold a sequence of characters, and its size is practically unlimited. We declare strings like this. String, space, surname, semicolon. We use double quotes to contain the string's value and can use the plus to join them together end to end. Basically, we can concatenate strings together, which is the jargon. Concatenate means basically stick end to end. For example, here we are declaring string first name, and we are automatically assigning it the value Peter. Please note, strategically, I've left a space at the end of Peter. We then also declare surname and full name, both of type string. Then what we do is we put in at our first name plus our surname, which is assigned above, and then it's concatenated with the plus sign, and we allocate that back to full name to place full name into the text of label 1. In all programming languages, there are certain rules about how we are allowed to express a variable name, and C# is not the exception. The rules are: they can only contain the following: letters or characters, digits, e.g. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and underscores. However, importantly, they must start with a letter, but can be as long as you like. Multiple declarations. Declaring variables, particularly if we had to declare a single variable per line, would make our source code extremely long. Therefore, we can declare variables of the same type on a single line, just like this. Int underscore top, comma, int underscore left, comma, int underscore width, comma, int underscore height, semicolon. Note that int top and int left are separated by a comma, and this is how we do it on one single line. Notice each of them are separated by a comma. We can also declare and assign a value on a single line, like this. So here's our variable, it's an integer type, and we've got int underscore counter equals or becomes 0, semicolon. A string can also be declared on a single line, as you've already seen. String underscore my full name equals or becomes Peter O'Neill, semicolon. Let's go back to integers. What happens when we type a line in the memory, into the memory of the computer? Well, in order to show you this, let's say int count. Okay. What we need to do is we need to have some sort of conceptual image. So when you actually assign a value, this is essentially what is happening, or shall we say conceptually, this is what is happening. So we assign it. So here is our computer memory, and as you can see, we've got a gap in the first run, and then we've got something in it and something in it, then a gap, and then something in it and something in it, and then a gap. Okay? So the ones with nothing in are empty memory. Now this is slightly not quite right, because remember our computer works in a binary format. So these single spaces in theory should have quite a few spaces in order to get the values in. So when we declare a value, a variable, like this, yeah, it says, right, I need a space that's large enough to take the biggest number that can be put into that. Remember, 2000 million, right? Now, obviously, it doesn't assign all that number, but it knows that it's a 32-bit machine, so it will allow up to 32 bits, which gives you quite a large number. Now, you can have long, and that will make it even larger. Okay? Now, in this example, because that's getting really confusing, in this example, let's just say that it puts in decimals instead. So it allocates the square there for count. So it says this is count's address, or where count is. And then when we assign the value to count, it essentially puts the value in to count. Okay? And that way it can always go back and get count in count whenever it wants it, because it knows where it is. Right, question for you. Who is the user? Any ideas? It used to be you, but it's not no more. You're changing your role, right? You've only just started to learn to program, but you are slowly changing your role. You are the programmer. The users are those that you, after programming it, will get the program, right? So the programmer will create all the functionality and all the variables, all the values, make them all available, and then a user just gets the program and runs it and can only see what's being done by the programmer. Okay? And only gets that functionality. They will not be able to see or change the source code. Only you can see that. They can't add objects, they can't add a text box if they wish, or they can't add a scroll bar if they wish. They can do none of that. They're given what you give them, and that is it. So, who is the user concerned? They will see what you make available on the form to them, e.g., what's in your window. Therefore, you have to ensure that everything they will need is available to them. If you are displaying money, you will want to create an interface maybe like this. Okay? So there we are, money. Yeah. So the largest do it was, now notice here we've got the current balance is 20, and it should be a comma, I would imagine. So it's 20,987.15. And notice here the largest debit was £10,123, and the largest credit was £40,000. 0.00. And you click on continue. Much a little bit like an ATM, I suppose. Okay, you can see that, by the way, in variables number 5, which is available to you on Blackboard, and you can download and save it writing it in. Okay, now message boxes are extremely important, and input boxes are also important. They are very useful for results, right? If you want to get something in front of the user, yeah, for example, your current balance is £2,000 and 80p. You don't want that in a big interface with lots and lots of other numbers. Yeah, if you want to bring their attention to it, to make them aware, say for example here, they're trying to withdraw £3,000, then you may want to put this up. Your current balance is only 2,000. In other words, you can't do that. You haven't got an overdraft facility. So you can do that. If, for example, we were going on a drive somewhere, and we put fuel in the car, and we can travel up to 900 miles on this fuel, then we might want to bring their attention at the start of the journey to the user that you've got up to 900 miles to travel on the fuel. And this goes on other things. Input boxes are also useful because what you can ask them for is confirmation. So you can also use them for warnings, like please enter your first name. So obviously the person, and they forgot to put the first name in. So instead of just sending them back to that point, you can just get the input box, get it from them, and allocate it to that box for them. So they're not having to look for it. Errors are a good point. You know, you should have entered a number. Please enter the number again. You know, stuff like that. So you can test for things. And there's other etceteras as well. So let's have a quick look again at message boxes. Did you notice that I had the phrase, you can travel up to 900 miles on the fuel? Now to display that, we have text which will always remain the same. You could have travelled up to space, notice the space, and space miles on the fuel. Okay? They're going to always be the same. What's going to be different is as we drive along in our car, the value of 900 is going to slowly deplete. Okay? So we may have a calculation that's time or speed and time or whatever, or revs per whatever, yeah, that works out how many miles we can do it on. And that will slowly come down. So we could actually create a message box. And it's probably the best way to do this as well. But we will need to join information together. So, in addition, we need to convert an integer to a string. Remember, types. Okay? Number is an integer. It may become a double if we're doing calculations on that. So, what we need to do is we need to make sure we use the .toString function on them numbers. So here, for example, we've got our button that shows our message box. Yep. And then we've got our string declared in miles. Okay. And then underneath that we've got the value of 900 miles. And then we've got the convert, and it puts string to miles, converts it. And finally, we've got our message box, which concatenates the three elements together. You could travel up to plus miles on the fuel. Okay? So we're going through it all there. Okay? And we'll add them all together, as I say, and get that. We could also use text boxes. And that means that we won't need to use our symbol to concatenate the phrase together to make it one whole phrase to fit in one message box. But we would still need to convert the 900 into a string because our text box takes text, which is strings. So we could put this into our text box in total. How will we do that? We'd split it into pieces, the three pieces that we had previously. So you could travel up to text box 2 for the actual number. Please note, because it's a text box, remember, we'd have to convert it from an integer or whatever value it is into a string, and then in the third box, miles on the fuel, like so. Okay, and we do this during design time. At runtime, we'd work out how many miles it is and insert that at that point. And they have two states. That's when I, as a programmer, am using it, which is called design time, because I can design it way it looks and change things about. And then the other time is runtime. So design time. So design time is when you, as a programmer, can add and change and manipulate components and objects. You can add text boxes, labels, etc. So what is runtime? Well, runtime is when the user gets to use the program. However, remember, they cannot add components, objects, change components or objects, manipulate components or objects other than the functions that you have already permitted. So they can only do what you've told them they are able to do. They are captive to what you have given them. Therefore, if the application does not do what they require, they won't purchase the product. They'll go and get it from somewhere else, which in the long term, as a software engineer, means you'll be out of a job. Back to text boxes. The difficulty with text boxes is the size. So, for example, if we had miles on the fuel and we don't create a box big enough, then the user can't see that. They might see what we've got on the screen here. If the user is wishing to type in a phrase, say word they're writing a book, and the program now provides a little text box like the one above, then it's going to be impossible for them to work. However, text boxes can have multiple lines, so we can actually change that. And the way we do that is quite simple. We click on our text box and then we find multiple line, and we set it from false to true. We can also put scroll bars on so that the person can move up and down and left and right in the text. You may also want to put wrap on as well. Once you have set the multiple lines to true, handles will appear on the corner of the text box so you can drag it to any size that you require. In addition, as I say, you can set wrap to true. This means that when it gets to the end of a line, it will wrap back round and come onto the next line automatically. Now, so here's an interface that I've designed. Notice, I've got a text box at the top, which is a multiple line. I've only got the vertical scroll bars on. And I've put in, Mary had a little lamb, its fleece was white as snow. Now, actually, the first line of this is, Mary had a little lamb. Yeah. So, really, we wanted to make its fleece was white as snow on the next line. Now, in design time, we press enter for that. Obviously, we can't do that when we're coding it. So there must be a way to get around that. And I'm going to show you that in a moment. But you can see that code in declaring variables number 7, along with the interface. So I have a look at that. As I said, really what I wanted, its fleece was white as snow, to be on the next line. So when typing, I will press enter or the return key. But how do I do it in design time? I use a function called environment dot new line. So here we are. Our text box is called poem, and it holds, that's what the box is called. The text itself is called text. Remember, is of type string. So I need to make sure that whatever's entered into it is of type string. So Mary had a little lamb, comma. Then I've got add to this environment new line. Then add to that open speech marks. Its fleece was white as snow. So now I've got a new line between the first line and the second line. And this is how we do it programmatically. We could also want to append text to it. So for example, we want to add to it another line, or some more lines saying, and everywhere that Mary went, new line, the lamb was sure to go. Now, if we just put dot text, when we click on that to add the other part, that button, to append the text, it would overwrite the first part. So actually what we need to do is we need to use the function called append text. So we'd use poem with append text. And this is how the line would look. So we've got txt, which is what I use for my text boxes, or txtb sometimes, underscore poem. So that's the text box. Then I want to append to the text itself new line plus and everywhere that Mary went, then a plus new line, the lamb was sure to go. So each line goes on a new line. So the new lines separate and we concatenate using our plus symbols. The final button, of course, was clear, which is dead simple, because all you do is type txt underscore poem clear, and it'll clear the text box for you. Okay, expressions. Here I provide more details on operators. So these are your operators: plus, minus, times, divide. Some of the new ones. Expressions are introduced via assignment statement. It is an important concept in general. Variable equals expression. Remember, equals should be read as becomes and not really as equals. Arithmetic operators. For example, arithmetic operations are addition, subtraction, multiplication, division, modulus, or remaining integer division, exponent or power of. So arithmetic calculations. However, consider the expression 6 plus 4 times 2. Is the result 20 or is it 14? In fact, C follows the algebraic convention in performing multiplication before addition, so the real answer is 14. Remember BODMAS. Brackets, order, division, multiplication, addition, and subtraction. BODMAS. So here we go. Prior to the calculation. BODMAS. Okay? innermost brackets first. Power of next. And then it's uh, multiplication, division, and modulus. And last, minus and subtraction. Subtraction and addition. If all these operators were the same priority, left to right order is used. With division, it truncates down if you're using integers. So 5 divided by 2 would equal 2, not 2.5. Any questions? Please email me or speak with me during your tutorials. Thank you for your time. I hope you've enjoyed this tutorial.
That's all, folks.